In this first part of our problem solving, we will define or formulate the problem. And we are going to discuss things like what are we solving for, what is my schematic, and that's a very, very important process for problem solving, and the given data, and we will note the assumption. So in this step, we really try to note down what exactly are we solving for. So here in this problem, there are two very interesting aspects. One is it doesn't tell us where we need to find the moisture. Instead, it says the most moist location. Now, if it is being dried from here, then the most moist location has got to be over here. So that means we need the time for the bottom of the layer to reach the particular moisture level. Okay, and then the other interesting part of the problem is that it doesn't give us the surface moisture. Instead, it asks for what is my surface moisture. That's because it's a convective boundary condition where the moisture content at the surface is not provided, but a convective boundary condition is provided, and the moisture at the surface keeps changing as drying progresses. Another way to look at this is that mass transfer coefficient at the surface is not infinite, and therefore the surface is not at equilibrium with the surrounding air. So the second topic, the second thing to do in this problem is to find the moisture content at the top surface. So here now we show the schematic. This is, as I said, is one of the most important step in problem solving. So on the left, we see the real thing, and on the schematic, on the right, a highly simplified version of the same. So in this one, for example, the two sides are impermeable. So we have no moisture transport on the two sides. Then the bottom layer is also impermeable. And basically, the drying only happens from the top. So this makes it kind of a 1D problem, as we'll see in a second. So as I said, this problem is now a 1D problem, so moisture can only go out this way. So it's a 1D problem where the moisture transport is in the x direction. This we have kind of no choice. It's kind of obvious that it's a 1D problem. First, because these sides are impermeable, and also we really, in this class, we haven't done 2D problems. They can be done without that much added effort, but we haven't done any 2D problems, so we must be doing a 1D problem. So there are other assumptions that are often involved. We don't get into these details because they are sort of implied, because if they are not, then the problem has to give you more data. For example, diffusivity does not change as the material dries. Well, that's kind of obvious in this problem because they only gave us one diffusivity value. If it changes, then we need to be given that. Then the dimensions do not change as material dries. We are given only one dimension. So then we pretty much have to assume this based on the data provided. So we're not assuming these things, we're not assuming these based on like our prior knowledge or something. It's simply based on the data provided. We have no choice but to assume these.